Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
So let's talk about the order, the order properties. What are the order properties out there? So the order properties are very simple. Okay. If an is bn by an is less than or equal to bn, then implies that the limit also holds the same thing. It's very simple. If you imagine that like this is going to this limit and these are all less than or equal to this. So let's say the same thing comes down. So this must be less than this. Okay. And here it goes to this. So all are less. So each individual are less. So therefore it's like shifting down. Okay. So this will be lesser. The limit will be lesser where the infinity tending happens. And this gives rise to the main thing that's called squeeze theorem. So that if an is less than or equal to bn and less than or equal to cn, then if this goes to same limits, let's say L, and this goes same limit L, this implies that an must go to L. Okay, and that's very basic idea. It comes from here. You apply this on this, that means L is less than or equal to an ka limit, and let's say A, and A is greater than or equal to L, and A is less than or equal to L. So from there you will get A is equal to L. It's a basic application of this. So you can also prove this using an epsilon and an epsilon like idea. Okay, so this is very interesting. And the most interesting idea that you should know is this, that if n is going to, so this is one of the most important idea. If you know is n is going to L, that means you know. Okay, let me give an example first. So I have done it already before. That if you take n is equal to sine n by n, or let's say cos n by n, all of them, which is bounded. So sine n with mod is less than or equal to 1, and by n will be less than or equal to 1 by n. And you know this is greater than or equal to 0 because you have taken mod. And this goes to 0 and this goes to 0. So therefore this must go to 0. Now this is useful because see, you cannot apply algebra of limits here because sine n doesn't converge because of the oscillation, right? So the basic idea is this: squeeze theorem is useful for combination of existing limits, like combination of non-convergent and convergent sequence. For example, as this. Similarly, it goes for cos n by n. Okay, so this is really helpful. So for the limit theorems, you should read the section of Cheenta-Ross. It's really beautiful. Like all the important questions are there and the proofs are given there. You should check the proofs out there, and these are very important. Okay. The sections. There are other examples, problems out there too. For example, I will mentioning this now, that these are basic theorems. They're all in Cheenta-Ross, and you can just think. It will enhance your understanding. You will not read this for problem solving per se, but it will enhance your understanding. Number one is this, that if Sn goes to S, then 1 by Sn goes to 1 by S. This is nothing but the algebra of limits. But if Sn goes to, if S is equal to 0, this comes from the algebra of limits because it's a continuous function, the composition. You're taking the function to be 1 by x. 1 by Sn is nothing but composition of f of Sn, where f is equal to 1 by x. So 1 by x is continuous at open 0 comma infinity, right? But if s is equal to 0, okay, if s is equal to 0, what will happen? If s is equal to 0, what will happen? Can someone tell me? Infinity? Is it infinity, minus infinity, or limit doesn't exist, or none of the above? In fact, the solution is all of them. And I will give an example. The basic idea is this: how can a sequence converge to 0? In three possible ways. So understand the geometry is very important. It can converge to like this, it's 0. For example, it's going from left hand side of 0, minus of 1 by n. Left hand side is decreasing, coming slowly, taking like this steps. 1 by n, okay, let's take 1 by n, where it comes like this on right hand side. It can oscillate, so it's minus 1 whole to the power n by n. For this it will go to 0. So now let's do it, let's inverse it. For inverse it, 1 by Sn will be becoming minus n. Here it will become n, and for here it will become n into minus 1 whole to the power n. So it will go to what? It will go to plus infinity and minus infinity. You can see that it will go to infinity and it will go to minus infinity. Oh, minus infinity. So once you understand the geometry of this, understand what's happening, it will get a clear idea. Okay, all of you got it? Yes or no? Give reaction, please. If you have doubts, please ask me. Essentially, infinity is like, if it's coming from negative, it will be like, if it's coming towards 0, 1 by Sn will be going towards, that's the basic idea. So always in terms of things, in terms of examples. Okay, why? Because your perception about behavior of sequence, this will happen. Once you increase more examples in this, your perception of behavior of sequence will increase, and therefore your algebra of idea will increase, algebraic idea. So therefore focus on building more examples. Like make a good list of your examples. That will help you out, guys. Okay, in your understanding of sequence. This is very important. So I'll probably make a homework. I will write down to myself. I will give a homework, a different homework of uploading all the known limits you have. That will be useful for you to check, but that will be a good chit chat. Okay, examples. Examples like this, all these examples. You will include these examples here, okay, which will show you more and more examples how it's happening. Great. What else? So how infinity happens? So the behavior of infinity is this. So we have understood the algebra of limits for finite things. For infinite things, it's like this. For infinite things, if an is going to infinity, let's say, and bn, if it's greater than 0, I don't know the limit, an by an times bn will go to infinity. Okay, it's understandable. This is one infinity. So one infinity result. Okay, so this one interesting result. If n is going to infinity, if and only if 1 by n goes to 0. Okay, one other interesting, if n is increasing and unbounded, then it implies that n is going to infinity. If n is decreasing and unbounded, and it's n is going to minus infinity. If it's bounded, it will, the limit will be there, right? That's what the MBT is there for. Okay, so therefore if I say n is a monotone sequence, and if it's unbounded, so therefore what happens? If a is monotone, that's why, and now they will check whether it's unbounded or bounded. It will either go to infinity or minus infinity, or it will converge if it's bounded. Got it? Or if it's monotone, it may not be monotone always. Okay. Okay, all of you got this. So therefore, how will you make your cheat sheet? You make your cheat sheet as algebra of limits. Under that heading, you will be giving finite limits, and there's algebra for infinite limits, and all these examples. You can get it from Kenneth Rosen, and whatever the ideas I have spoken about, it's like the basic things. Okay, I'm just telling the geometry of this and order properties, the inequality stuff. These are all equalities and these are inequalities. This is all the algebra of limits are there. So this makes the essential whole thing about algebra of limits. Functional form, you need the list. I'm writing the list which you need to create, the list of all known formulas and whatever you're gathering every single time. So you will get to understand with more examples of sequences, you will get to understand the behavior that's happening and it'll get into your mind because we learn by examples. Okay, it's like role models for sequences. You learn by examples, and that's how human beings have been striving so forward in all the aspects of his or her lives. Okay, so in their lives, so the list is very important, and algebra of limits, of course. Another main idea is the differential calculus, which you learn later on. The other aspects are some extra stuff which we'll do later on, like in the class only. Extra, it will be a special class. So this is all about functional form. Okay, how do you deal with functional forms? The examples I will be uploading problems. So in IIT, there are three types of questions. One is functional form, FF. One is recurrence form, and one is the behavior questions. Cauchy sequence, whether n will be decreasing, increasing, whatever, bounded. For functional form, I already told you, and behavior, which will be taught in the other classes, and reference, and this recurrence functional form.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.